This video is actually a pretty vocab-heavy video as well. We're dealing with arithmetic sequences, and one of the tasks that you'll be asked to deal with is to look at a pattern, notice the pattern, and then give either the explicit or the recursive definitions of it. It is a really cool skill to have, but a lot of teachers will give it to you just as a formula, and I, as you know, hate formulas. So instead, I will show you the way that I think about this, and you can let me know if it's useful. The big takeaway, though, is that you know what an arithmetic sequence is, so I'll give that to you up front. An arithmetic sequence is a sequence that's defined by a constant addition, so you are adding something to every single term. It's actually really similar to a linear equation, but whereas a line is like every single point that's connected, and you can even plug in like decimals, a sequence is just the concrete like individual numbers. So there's a first term and a second term and a third term, but there's not like a first and a half term. There's nothing in between them, and that's the biggest key difference between the sequences that we're learning now and the linear equations that you would have done earlier. So let's consider the arithmetic sequence that is defined starting with the number 11, and then it goes up to 14, and then it goes up to 17, and then it goes up to 20, and then presumably extends infinitely. You should already be able to see that this is a situation of just plus 3. And so plus 3, in this case, is going to be the thing that we use to deal with defining this sequence. Now, the easiest way to do this, I always think, is to start with the recursive definition, because we saw how easy it was to come up with the recursive definition a moment ago. So my recursive definition, if you remember, is one that gives like the first term and then how you find all the rest of the terms. And since we've already said out loud what that is, it's just last term plus 3, you just add 3 to the next one, then we can do that really easily. A sub, and again, I like to start with 0. You can start with any number you want, but it's much, much, much more powerful if you give 0 as your initial term. So if a sub 0 is 11, then a sub any number k is going to be a sub k minus 1, the term that came right before it, plus 3. Since our common difference was 3, we've nailed it. So if this is our recursive definition, has 2 parts, my initial term a sub 0 and my recursive formula. I can use that to figure out what my explicit formula will be. And I'm going to do that. What's the easiest way to do this? Yeah, I'm going to go with it. I can find any of these numbers by taking a sub k and plugging in k by however many 3's I've added. So if I'm finding the 0th term, I'll plug in 0 3's. If I'm finding the second term, which is a sub 1, then I would plug in 1 3. If I'm finding a sub 2, well, it took me 2 3's to get there. So really, I just take my first term, 11, and add 3 times however many terms I've gone through. And this will hold true for anything all the way up to the 507th term. So instead of having to do 506 intermediary steps, I can get immediately to the answer that I want. I think that's enough for this video.